Morning. Today we are going to talk about the mass of atoms and substances. First, I'm going to make a review of what we studied about atoms mass in Unit 4. Okay, so this video is about Unit 4, a review. So first of all, we are going to review what is the difference between the mass number and atomic number. Mass number, represented by A, equals protons plus neutrons. Protons and neutrons are the particles inside the nucleus of the atom. And atomic number, represented by Z, equals just protons. Okay? Today we're going to focus in mass number. Okay? In Unit 4, we studied that the relative atomic mass is the mass of an atom compared with 1/12 of the mass of a carbon atom, the isotope 12. Remember that we used plasticine in class to understand what the relative atomic mass is. If we have a look to the periodic table and we choose, for example, the element helium, the element helium has 2 protons and 2 neutrons in its nucleus. This gives us a mass number of 4. It means that it has a relative atomic mass of 4. But for what? The relative atomic mass is a unit of measurement based on a comparison to something. That something is 1/12 of the mass of an atom of carbon, isotope 12. So we say that the mass of an helium atom is 4 times heavier than 1/12 of an atom of carbon, isotope 12. As we look through the periodic table, we notice that almost all the elements have decimal numbers in their atomic mass. So in the case of helium is 4.003, fluorine 18.99, nitrogen 14.01. This is because elements can exist with different number of neutrons. The elements that have same protons but different number of neutrons are isotopes. Since each isotope has different mass, to know the mass of the element, we calculate the average of the different isotopes. Example, chlorine. We have the element chlorine. We can find chlorine with the mass number of 35 and 37 mass number. The abundance of each isotope is 75% and 25%. So to calculate the relative atomic mass of chlorine, we multiply the mass number times its abundance plus the other mass number of the other isotope times the abundance divided by 100, because this is a percentage. So we find that the relative atomic mass for chlorine on the whole is 35.5. It depends on how many decimals we take. As you can see, chlorine in the periodic table, in this periodic table, is 35.45. But rounding the number is 35.5. So this is the review of Unit 4.